Welcome to this video tutorial on AS Surds. One thing that you'd be glad to know is that the Surds that you would have been taught at GCSE is going to be virtually exactly the same moving forward onto A-level maths. The only difference is that you will see Surds being used a lot more in other topics. So what we will do is we will go through what you would have learnt at GCSE and just taking it up a notch with regards to some of the questions. So as I've previously mentioned, Surds at AS level isn't really that much different to what you may come across at GCSE. The only main difference is the fact that questions might be slightly written differently, and also that Surds are also used in many of the other future topics that you will come across. Now, Surds is one of those Marmite topics. Students either hate it or they love it, and it's one of those things that is really important that you do get your head around what it is and how it works and why we use them. Now, one of the main reasons of why we use Surds is when you start dealing with complex mathematics is that there is a massive need for you to use exact values, and one of the rules of maths is that you should only really round up your final answer. So if you are dealing with quite complex numbers, and when I mean by complex numbers I mean like 16 decimal places, that you then want to, if possible, write your numbers as a Surd, just like you would prefer to use a fraction. And it's also very easy for you to write rather than a massive long number. So as it says there, is that Surd is an exact way of writing an irrational number, and this is generally in the form of a square root. So if you have one of these more modern calculators and you work out a question, you might find that your calculator automatically gives you in a Surd because it will automatically give it to you in its exact form. You just have to press the SD button and it will convert it for the decimal. Now, there are two main rules of Surds. One is the multiplication rule. So when you have got a number and it is a product of two numbers, you can split that up into two separate square roots, multiplying the two. And the second rule is that if you have got a number that can be written as a fraction, then you can split the numerator and the denominator into two separate square roots. So the first thing we come on across to is simplifying Surds. So we can simplify Surds if the number inside is a multiple of a square number. Now, before we even start this, one thing that is worth doing is that if you're one of these people who've never really understood Surds, is that it's really important that you know your square numbers. So obviously if we just start with the first few, so we've got 1, 4, 9, 16, 25, 36, 49, 64, etc. And I would say it's really useful for you to go up to your 16th square number, so going up to 256, because by knowing and recalling your square numbers, it's really useful for this topic. So for example, when you want to simplify root 18, so you want to think to yourself, is there one of these square numbers that is a factor of 18? And as it says in the top tip there, if you think big, there's going to be less work, in which I'll go through some examples when we do later on in this video. So I can write 18 as 9 times 2. So what I've done here is using that first rule of Surds, of when I can write the number inside the Surd as a product of two numbers, that where one of them is a square number, I can then actually work out what root 9 is, which is 3. Obviously, I don't know what root 2 is, so I can simplify that answer as 3 root 2. If we then move on to 72, so you want to think to yourself, which of these is there a square number is a product of a factor, of 72, in which 36 is. Now, obviously, I could use a range of numbers, but the bigger you think, the easier it's going to be. Otherwise, you'll have to, like with equivalent fractions, you'll have to keep going if you think small. Whereas if you think big, there's less simplifying for you to do. So here we've got 36 times 2, which is 72. And obviously I know the answer to root 36, which is 6. So I'm left with the answer of 6 root 2. If we move on to example 3, we've got root 10. Now here, there isn't one of these square numbers that is a factor of 10. So although 1 is, again, if we're using 1, really I shouldn't even be using 1, so let's just get rid of that, because we'll end up with the same answer. So here, this one cannot be simplified. So don't think that every single question that you get, or every Surd, or any number that's inside a square root can be simplified, because that may not always be the case. And as I said, try and think and find the biggest square number that you can think of, because obviously therefore it means less work. So for example, if I had the square root of 200. Now I know that that is 4 times root 50, which I can simplify root 4 as 4 times root 50. But then I can also then write this as 25 times 2, which leaves me with, oh, I forgot the square root, 5 times root 2. So bringing that 2 down, I get 10 root 2. However, if I thought of 200 as being 100 times root 2, then that automatically straight away gives me the correct answer without having to do any of this faff. So if you think big, less work. Obviously, if you're struggling, then you can break it down, but just bear in mind that it will take a little bit longer to get to the final answer. And also it's worth checking to make sure, can I simplify this number here before continuing? Now, another form of simplifying calculations are questions like this. Now, what your mind should be thinking of is collecting like terms. So if we just go through step number 1. So with this here, we've got 2 root 6 plus 3 root 6 plus 5 root 7. Now, how you want to think about this is if you treat the root 6 as, let's say, collecting like as letters. So if we treated this in the exact same way, if you just bear with me, I'll just color code some of these. So how we approach this question is if we had 2x plus 3x plus 5y. Now here all I've done is I've replaced root 6 with x and root 7 with y, and collecting like terms here, what we'd end up with is if we join these two, we end up with 5x plus 5y. And obviously then replacing the x and the y with root 6 and root 7 respectively, we get the same answer. Now from this you would never then go on to combine the two to make 10xy, and the same thing applies with surds. So as it mentions there, that this here would be your final answer, nothing else. So if you just bear with me. So this would be your final answer and nothing else, and that's where it'd be left. Moving on to example 2. So here I've got 3 root 5 times. So here when we're multiplying, again, similar way with regards to simplifying algebraic sort of expressions, is the fact that when I'm multiplying, I can multiply numbers with numbers, letters with letters, and here what I do is I multiply numbers outside the respective surds and multiply the numbers inside the surds together. So here I've got 3 times 2, which is 6, and 5 times 6, which is 30. Now when you have done this, one thing to bear in mind is to think to yourself, can I simplify this? So is there a square number that goes into 30 so I could then go on and simplify that further? Now in this case there isn't, so the answer therefore would be left as 6 root 30. For example 3, here we've got 10 root 30 divided by 5 root 2. So here what we can do is we can write this as a fraction, and then once we've written it as a fraction, it kind of comes a little bit easier for us to work through. So if I just write number 3 here, so if I've got 10 root 30 over 5 root 2, so if I simplify the 10 and the 5, I then get 2. And looking at the second rule of surds, when I'm dividing, I can divide surds with surds. So 30 divided by 2 gives me root 15. And again, think to yourself, can I simplify root 15? Is there a square number that goes into it? No, there isn't. So that there is my final answer. Looking at example 4, we've got square root of 9 over 14. So here, what you want to note, and what you should probably notice if you get these questions, is that one of them you will be able to simplify, or one of them would be a square number, which in this case our square number is 9. So with number 4, we've got the square root of 9 over 14, and using the second rule of surds, we've got root 9 over square root 14, I can simplify root 9, which is 3. I can't simplify root 14, so I just leave it as root 14, and there is my final answer. Now, one thing to note is, just like with fractions, so for example, if I had, let's say, 10 over 20, that obviously I can simplify that by dividing both numbers by 10, in which I get a half. But then, just like you would with fractions, you don't go any further. So here I'm not then going to continue dividing by, let's say, divide by 2. So I've got 0.5 over 1, and then 0.25 over 0.5. Because just like with fractions, you can't write decimals using surds. So here it's definitely worth noting is that you cannot write decimals inside a surd, because otherwise there'll be nowhere for you to stop. So you stop when you are going to go into that stage, and there is your final answer. So here are a few examples just to test your understanding of what we have discussed. If you'd like to pause the video to have a go at some of these questions, please feel free to. Otherwise, let's get started and work through some of these examples. So we start off with question 1a. So question 1a says root 18 over 3. So what we're going to try and do is simplify root 18. So we ask ourselves, what square number goes into 18, which is 9. So I've got root 9 times root 2 all over 3. We can simplify root 9 as 3. So what we are left with is 3 root 2 over 3. And then the 3's cancel out, leaving us with just root 2. With regards to b, what we've got here is we've got 3 root 2 minus root 8. We can simplify root 8. So our thinking is that we want to try and obviously get a root 2, so we can actually simplify it. So here we can rewrite root 8 as root 4 times root 2. Root 4 simplifies to be 2 root 2, so we've got 3 root 2 minus 2 root 2, leaving us with root 2 again. Moving on to question C. So what we have here is we have root 6 over root 3. So using the second law of surds, we can write this as a single division. So we've got root 6 over 3, which lo and behold, and coincidentally, gives us root 2. Moving on to example 2, so we'll just quickly rub all of this out. Here we are collecting like terms but in surd form. So what we have here is, just get my pen. So number 2, we've got root 12 plus 5 root 3. So here we've got a clue in the fact that we know we're going to end up with 3. So here we can rewrite root 12 as root 4 times root 3 plus 5 root 3, which then gives us, we can write this as 2 root 3 plus 5 root 3, which equals 7 root 3. And then for B, we've got root 200 plus 7 root 2 minus root 72. So again, if we try and think big of the biggest square number that goes into 200, I can write this as root 100 times root 2 plus 7 root 2 minus the biggest square number that goes into 72 is 36. And simplifying all of that, we get 10 root 2 plus 7 root 2 minus 6 root 2, leaving us with 11 root 2 is our final answer. Moved on to the double brackets questions. So what we have here is, let's create a bit of space. So from here, looking at question 3, we are going to expanding our double brackets. So we've got root 5. I don't know why I wrote root 3 there. So we've got root 5 minus 3 root 5 plus 2. So here we've got root 25 plus 2 root 5 minus 3 root 5 minus 6, which we can rewrite this as 5. which then leaves us with minus 1 minus 1 root 5. And there is our final answer. Don't forget that it's minus 1. And for B, we've got, so here the difference between this question is we've got numbers in front of our surds. And so we've got 4 root 3 minus 1. So again, remembering that we can only multiply numbers with numbers, outside numbers with outside numbers, numbers inside surds with number inside surds. So for this times this, what we end up with is 8 root 9 minus 2 root 3 minus 16 root 3 plus 4. This then simplifies to be 4 times 3, which is 8 times 3, which is 24. Minus 2 minus 16 is minus 18 root 3 plus 4 gives us a final answer of 28 minus 18 root 3. Then finally we move on to rationalising the denominator. So moving on to question 4, what we have is rationalising the denominator. So for question A, we've got 9 over root 3. So what we do here is we multiply both the top and the bottom, so the numerator and the denominator, by root 3, in which we get 9 root 3. Root 3 times root 3 is root 9, and root 9 is 3. And then we can simplify the 9 and the 3, leaving us with a final answer of 3 root 3. With regards to B, we've got 16 over 3 root 2. So even though we've got two sort of things in our denominator, it's still a single term. So I multiply both the top and the bottom by 3 root 2. And if we multiply out the top, we get 48 root 2 over 9 root 4, which leaves us with 48 over 2. 9 times 2 would be 18, leaving us with 48 over 18. We simplify that by dividing both numbers by 6, so we get 8 root 2 over 3. Moving on to our next question, which is C. So here I've got 1 over 3 minus root 2. So here we've got two terms, in which, remembering what I mentioned earlier, the fact you need to reverse the sign that's in the middle. So here what we're going to do is we're going to multiply both the top and the bottom by 3 plus root 2, which leaves us with 1 times. Now if we treat this as like a double bracket question, what we end up with is 3 plus root 2 over 3 minus root 2, 3 plus root 2. Now, as we said, as this rationalised denominator, we're not really bothered about what the numerator looks like, so you can leave that as messy as you like. So we're going to leave that alone, not going to touch that or attempt to simplify that. And what we end up here is expand the brackets, we get 9 plus 3 root 2 minus 3 root 2 minus root 4. These two things cancel. Root 4 is 2. So here we end up with 3 plus root 2 over 9 minus 2, which leaves us with 3 plus root 2 over 7. Then moving on to the second one, the last one, sorry, and we end up with, let's just get rid of all this. And with the last one, a little bit more complicated because it just looks a little bit messy, but still the method is exactly the same. So we've got 2 root 2 plus root 3 all over 2 root 2 minus root 3. So here what we're going to do is we're going to multiply both the top and the bottom by the new denominator, reversing the sign. So in this case it's going to be 2 root 2 plus root 3. Now one thing you should spot is the fact that both the two numerators are going to be the same, so how I could write that as is 2 root 2 plus root 3 squared all over 2 root 2 minus root 3 2 root 2 plus root 3, and if we to expand the denominator out, so 2 root 2 plus root 3 all squared over, so 2 multiply the outside the numbers, so we've got 4 root 4 plus 2 root 6 minus 2 root 6 minus root 9. This here becomes 4 times 2, which is 8. These two things cancel out and that becomes 3. So all we're left with is 2 root 2 plus 3 all squared divided by 5. And there is your final answer. So there we have correctly rationalised the denominator, and we can then go from there. And that is Surds in all its entirety. Thank you for watching. If you have any questions, please feel free to ask.